Okay, hello everybody. Thank you for being here. My name is Ali, and today I'm going to present you the topic of my master thesis. It's about direct access. It's a security assessment for this technology. As Inu said, and first of all, I would like to thank him for giving me this great opportunity to present my topic in such an occasion. So, to begin, today, I'm willing to cover these points actually at the beginning, introduction about the objective and also some basic information about the direct access, which should we know. Also, I'm going to tell you in a few slides about the direct access lab that I implemented in order to perform the task. And finally, before I reach the conclusion, I'm going to tell you, the exact result that I got from the assessment that I have performed. So let's begin. What was the objective behind the thesis? Actually, it was to assess the direct access, but not everything, because actually, if you look at direct access, it's really huge technology and has many different technologies that participate in order to make this technology works. So we decided to look at something that, as Inu said, that has not been done before, which is, looking at the impact of using IPv6 on this technology. Also, I did some marginal tasks by looking at some critical components of direct access, such as the IPsec configuration that are applied by default by the group policy, and also at the TLS component, which represents a major and main part of this technology, at least in our scenario, which is used to tunnel the IPv6 traffic when the client is on IPv4 networks. So, what is direct access? Direct access simply is an IPsec VPN technology that purely based on IPv6, and also unlike the traditional VPN solution, direct access actually doesn't require the user to enter any credentials. So no matter the user his location is, the user is always connected to the internal network without, interaction with the user by any means. So he doesn't need to provide any credentials like in normal VPN connections. Also, in direct access, there will be more than one IPsec connection. There will be two, actually. One is going to the infrastructure servers, and the other one is going to the resources themselves, which carry the actual user traffic. Also, direct access has a big advantage of letting the administrators to manage and administer the remote connecting devices and seeing if everything is fine, if the device is already patched and already updated, and so on. Also, enhanced security features, since direct access uses, for example, for every IPsec connection, multi-factor authentication, like using certificates, also using some authentication protocols such as NTLM version 2 and also Kerberos. And also, regardless that this technology is IP version 6, but also it has the possibility to work over IP version 4, which we will see later on, like using, for example, some tunneling technologies such as Teredo 624 and also IPHTTPS, which is a proprietary for Microsoft. Like any technology, of course, there are some drawbacks, as some, for example, discussed. For example, not all operating systems from Windows are supported. Up to, for example, Windows 8.1, only Windows 7 with Enterprise and Ultimate are supported, and also Windows 8.1. Otherwise, you cannot use it. Of course, Windows 10 is also supported for, DirectAccess is also supported in Windows 10. Also, there are some security features that sometimes are not possible to be used, such as end-to-end encryption. For example, if we want our traffic to be, fully encrypted from the DirectAccess client until the resource inside the internal network, it might happen that the server that holds this resource, for example, uses Windows Server that doesn't support IPsec over IP version 6. Also for tunneling, when, for example, the organization or the enterprise wants all the traffic from the users, despite the traffic is, for example, going to the internet or going to the internal network to go through the IPsec gateway, then sometimes it's very difficult to achieve, especially when the Windows Server, it's one of the old versions like 2008. Another drawback is when we use the so-called IPHTTPS. It's a new tunneling technology from Microsoft, which tunnels and carries the IP version 6 traffic over the IP version 4 internet inside HTTPS payload. So it's just like an application which carries actually network layer of IP version 6. And the overall, of course, complex system. So, on the right side of this slide, we can see the main components that should be available in any environment that we would like to use the DirectAccess inside it. Such as, for example, we have to have Active Directory, we have to have IPsec, public key infrastructure, HTTPS server running as network location server. The server actually is a critical component also inside the system, because through this system, through this server, actually the client knows exactly if it is on the internet or if it is inside the COBNet by, letting this server only accessible inside the COBNet environment. Also, the so-called name resolution policy table, it's a policy that is applied by the configuration of Microsoft DirectAccess, which tells the client where or how, for example, to resolve some DNS namespaces, whether to resolve these DNS namespaces using the DNS server inside the COBNet or whether using the DNS server which is by default configured on the network interface card. Also, sometimes we need NAT64 and DNS64 to translate the traffic if the traffic is going to some IP version 4 resources and vice versa. Some other components like Forefront Unified Access Gateway, this is also required in some Windows Server versions to deploy DirectAccess. So, to see how, for example, how this technology works, we are going to look at the main interactions between the server and the client in order to establish a secure connection. So I will skip here the part where, the client identifies its location on the internet, and as soon as the client knows that it is on the internet, then the client tries to locate the domain controller. And in order to locate the domain controller, the client will consult the name resolution policy table to resolve the DNS namespace of the domain controller. Then the name resolution policy table will tell the client, okay, you have, for example, to resolve this namespace using the DNS server that is located on the COBNet. So when the traffic or when the DNS packet goes to the IP stack, then it will be checked against the firewall security rules, and then the security rules will tell the client, okay, you have to establish IPsec connection. And this is where it comes, the first IPsec connection, which goes to the infrastructure server, the domain controller. So, and because the DirectAccess client is configured to use, for example, the IP HTTPS tunneling technology, then the DirectAccess client will establish an HTTPS connection by, first of all, using a TLS handshake. This TLS handshake will end up by sending an HTTPS. Where is the cursor? Yeah. This TLS handshake will end up by, this is from the standard, for example, after a successful TLS handshake, the client will send asking for this resource and for this content type, this number. And when the client gets 200, okay, then the client is connected to the subnet, let's say, of the IP version 6. And now the client has IP HTTPS interface that is in dormant state, and this IP HTTPS interface is going to be enabled. And to enable IP HTTPS interface, it's like in any IP version 6 network, the node is going to, to do a complete neighbor discovery protocol. So here we have the HTTPS tunnel established, and we will have the complete neighbor discovery between the DirectAccess server, which acts as the router of the subnet for all the DirectAccess clients. So by looking to this complete neighbor discovery, we will see here at the beginning, if the IP HTTPS, for example, interface hasn't been used before, then it will configure its local link, and then we'll send with this local link a router solicitation and gets a router advertisement back, and then configures the rest of IP version 6 global addresses. Okay. After this, the client will have its IP HTTPS interface up and configured with all the necessary configuration parameters. Then the client will use its certificate first and NTLM version 2 to authenticate the first IPsec connection that goes to the infrastructure server. And we'll authenticate it, and we'll build this tunnel, and we'll make the DNS conversation for this, to ask for the IP address of the domain controller, and then we'll contact the domain controller. This situation will stay the same. Despite, regardless the DirectAccess, the user is logged or not logged to his computer, because this is an automatic way. But if the user, for example, logs in with his credentials and wants to access, let's say, to his mail client, to his mail server, then there will be another IPsec connection, which is called intranet IPsec tunnel, that will carry this one, and it will be authenticated again with the certificate. And now, unlike the first scenario, will be another authentication mechanism called Kerberos, and we'll authenticate this tunnel, and we'll build it, and there will be DNS conversation again to ask for the IP address of the internal resource, and then the internal resource will be contacted. So this is the situation at the end. There will be like IP HTTPS tunnel, which carries the IP version 6 traffic inside the internet, and inside this IP HTTPS tunnel will be two IPsec connections. One is going to the infrastructure, and the other one is going to the resources. This one is always on, but this one is on demand when the user wants to access some resources, so this one is enabled. So to assess this, this scenario, the attacker or we have to build, or we have to be in the subnet as other DirectAccess clients. And to be on the subnet, we have to create this outer tunnel, because when we create this outer tunnel, what we need actually is just, the ICMP version 6 packet to try our IP version 6 basic attacks. So in order to do that, I had to develop a small script that behaves the same way as the normal IP HTTPS interface, using Python and SKB. So the lab deployment, how the lab was deployed actually, I followed the deployment guides from Microsoft to build the lab on a hypervisor, as you see here. For ex You hear it also, okay. Okay, so the lab, the hypervisor hosts all the virtual machines that running on the CoreNet side, and I have also an internet subnet inside the hypervisor itself, because I didn't want my, for example, lab environment to be accessible from the internet. So I gave the emulation for the clients that they are on the internet. And I have a Cisco and also a Cisco router, and also I have an Ubuntu machine that I use to perform my attacks from. And I connected my attacking machine to the hypervisor to be in the same internet subnet inside the hypervisor. And inside the Ubuntu machine, I used some tools to perform the assessment, of course, Wireshark to monitor the traffic, and I used Chiron attacking IP version 6 attacking framework by Antonius, and he really helped me. Thank you, Antonius, to get this scenario work, because in IP HTTPS, when you use the tunneling, there will be no Ethernet frame to adding to the packets. So what we see inside the IP HTTPS interface, IP HTTPS tunnel actually is just a pure IP version 6 packet without the Ethernet frame. So there are no use of layer 2 addresses actually. So in order to do that was really, a problem at the beginning, because there was no such tool that gives you like the only IP version 6 packet without the Ethernet frame. And what Antonius actually did, he reformed some modules inside the Chiron to make it suitable for my scenario, actually. And I used Scapy also, and together Scapy with Python, I developed a small script that behaves exactly as the IP HTTPS interface by tunneling the IP version 6 packets that I used to attack the direct access. And I used on the other side, on the Windows operating systems, some monitoring tools like Windows Message Analyzer, Network Monitor actually, and Wireshark, because I saw at the beginning when I used one tool, I saw that the different tools actually parse the packets in different ways. Sometimes, for example, the router advertisement is not fully parsed using the Network Monitor and Message Analyzer, while using the Wireshark parses the packet as it is. So the configuration is just the default configuration of the direct access when you just follow the wizard. But I used different scenarios for the IP HTTPS, since the default configuration of IP HTTPS, it's the default configuration doesn't use any authentication mechanism. So it's just like normal HTTPS connection to any server on the internet without client certificates. But I did change this scenario to see if there will be different attacks possible when, for example, the client or the attacker has a compromised certificate in this way. The IPsec protocol is ESP, and the Windows 8.1, this is an enhancement feature, because as we said before, there will be like a performance degradation when IP HTTPS tunneling is used. And Windows recently released or found a way to enhance this by using null cipher, but this is only possible in Windows 8.1, but also is not always possible, because when I changed the authentication mechanism in IP HTTPS, then I couldn't use null cipher anymore, even with Windows 8.1. So this is the topology that I used. For example, all of these running here actually are deployed in this scenario. So I have the CoreNet here, and I have the internet side. I don't have like a local subnet for the direct access client or something, but It's just on the internet and gets gets an IP address directly from the ISP server that running inside the hypervisor. And also the domain controller here runs as DHCP and DNS and so on. Here the certificate authority that issues the client the different certificates that they need to authenticate themselves to the direct access server. And the topology here, it faces the internet without DMZ zone or without any, firewall in front of it. So the assessment, as I said, I assessed two different scenarios. The first one is the default configuration for the IP HTTPS tunnel. And in this scenario, there will be no need for any authentication. So any device, any IP HTTPS capable device can directly connect to this direct access server. And the second scenario, I changed the configuration at the direct access server by changing the component to use authentication and to ask the different clients to provide their certificates before. And the attacker, I assumed that the attacker knows the URL or the IP of the direct access server, which is, publicly known because the direct access clients want to know, the IP address of the direct access server when they are on the internet. So they have to ask the public DNS server for that. So it's publicly known. And to assess this scenario, the authenticated IP HTTPS tunnel, I extracted one of the legitimate certificates from one of the direct access clients to perform further attacks using in this scenario. And the final assumption was, to assume that the attacker is anywhere, so the attacker can initiate his attacks from anywhere in the world. And in some cases, I assumed that the attacker on the local subnet. So this is the first scenario. So the attacker can build easily the IP HTTPS tunnel, which is the first. In my case, for example, I developed a small script, and using this script, I could be able to connect to this to the direct access server without any authentication. Yes, this is a lab deployment, but it might happen in the wild that some companies or something they use, for example, the outer tunnel, the IP HTTPS tunnel without authentication, because they think, for example, the real connection is encrypted, and also, for example, they think that it's authenticated, and they cannot, for example, access some resources here. Yes, we cannot access some resources, like, for example, asking for some web pages on some web server inside the COPNET, or accessing some mail server, but we can reach them using the ICMP version 6 packet. But I saw that the IP HTTPS component here on the direct access server, in case there is no authentication, doesn't forward the packets to the client if the destination address of the packets are a unique cast addresses that they are going, they are not, coming to the direct access, so the addresses are not the direct access server addresses itself. Or if the destination address of the packets sent by anyone, by the attacker or by legitimate direct access server, is going to multicast addresses, so they are just dropped unless the packet is router solicitation packet. So let me show you in very quick how so I am connecting to the switch where I connect to the internet subnet here, and this is, for example, and yeah, so this is the script that I developed. So as input, it accepts the certificate authority and the DNS namespace of the direct access server. So both of them, and this is the script. And then if I hit then I got it work. It's connected actually. And here, we said that at the beginning, it will be something like complete neighbor discovery, and this is actually a router solicitation. We can look it on Wireshark. Then yeah, so this is the interface that was created. And then if I go here, so this address is the local link address of the DirectAccess server. If you just copy this, and for example, if I ping 6, Python yeah, and I got reply here, or by its reply from here, and I can see in Wireshark this is the request and the reply. So yeah. So coming back to the presentation, sorry guys, it's unintended error. So we saw the first scenario, and the script was connected successfully. The attacker was connected successfully to the DirectAccess server through the IBHTTPS Python script. So this was what we saw actually. The connection was established, and the interface was created with the global IP version 6 addresses from the prefix that was advertised from the DirectAccess server. So what the attacks that were successful in this scenario, although that, as we said, some packets are dropped when they are going to the unicast addresses that are not belonging to the IP version 6 addresses of the DirectAccess server itself, or if the destination addresses are multicast unless the packet is router solicitation. But there are some attacks. For example, the attacker can scan a live host inside your corpnet because he can reach them, for example, using the ICMP version 6 echo request. And also, the attacker can scan for a live DirectAccess client because at this point, for example, server replies on behalf of clients. For example, in normal IP version 6 networks, when a node wants to configure an IP version 6 that already configured with another node, then the other node will answer that this IP version 6 address is already in use. But in this case, because IBHTTPS server component at the DirectAccess server doesn't forward the packets with multicast addresses, but the server replies actually on behalf of these clients because they have a neighbor cache entry on the neighbor cache of the DirectAccess server. So in this case, the attacker can know if an IP version 6 address is already in use and if there are some DirectAccess server that are connected. Also, send packets with a spoofed IP version 6 address. Actually, you can spoof any IP version 6 address if you know some that are used by some DirectAccess client. You can use them as source address, and you can send them because most of the check is done against the destination address. So when it comes to the DirectAccess server, the DirectAccess server actually willingly forward these packets to the destination, and the destination will reply actually this spoofed IP version 6 and not the attacking, even though the packet coming from the attacking IPHTTPS connection. Also, because the IPHTTPS tunnel doesn't use any authentication, the attacker can, of course, denial of service the IPHTTPS component on the server side. Also, neighbor cache exhaustion may, I say may, because may be possible and maybe not, but I saw that the DirectAccess server, which runs actually on Windows Server 2012 R2, using the RFC 7048, which defines a new neighbor cache entry called unreachable, which stays actually much more time than the normal incomplete state. So in this case, for example, if the attacker knows, and actually in DirectAccess, the attacker knows the internal subnet, he can ask the DirectAccess server to send, for example, a sync packet to multiple clients, let's say /64 of the prefix, and then the server will try desperately to locate this host, and by the time the server may, be under denial of service. Man-in-the-middle attack. Actually, this was really interesting attacks, because the IPHTTPS tunnel is the only tunnel that is used by the client to transfer the IPsec packets. But in this case, I used like ordinary fake router advertisement that has all the parameters, all the same parameters that normally advertised by the router advertisement, and I could be able to establish a new IPsec connection through the attacking machine. So the attacking machine got all the IPsec packets from the DirectAccess client on the local subnet, and then the attacking machine actually transfers these packets inside the IPHTTPS tunnel that is established between the attacker and the server. We will see this attack later. Spoofing attack, as I said. For example, this is the IP version 6 packets up here that are used by the IPHTTPS interface that I created. And here I used Chiron to send, for example, just a simple ping packet using this spoofed source address, which is actually was an address of one of the legitimate DirectAccess client on the lab. And here I was monitoring the server, and actually the server got this packet and forwarded to the internal server, and then the internal server respond to the same address, and then the DirectAccess server, because this is IPHTTPS connection, respond to the DirectAccess client here, and not to the attacking machine, for example. So there is no any check from the server side for the IP version 6 source addresses. So this is what I told you about the neighbor cache exhaustion that might happen, because it follows the 7048, and here unreachable state. Here all the layer 2 addresses are zeros, because as I said, the IPHTTPS actually doesn't use any information from the layer 2. The buckets are just pure IP version 6 address. And here the unreachable state, as this RFC said, it stays like until 60 seconds, this state. But I haven't actually, to be honest, to try all the 64 subnet to force this one to be under denial of service. This is the scan connected DirectAccess clients. For example, I sent packets with unspecified address, but what replied me actually was the server got the packets here. This is the IP address of the attacking machine. This is the DirectAccess server, and this is the DirectAccess server replied me, and this is 8080, which is the hexadecimal of neighbor advertisement. This is the second scenario where the attacker actually has hands on a legitimate client certificate, which I extracted using Mimikatz, for example, just for a demonstration purpose that the attacker may have this certificate. It's not that difficult, and motivated attacker, I think, has no problem for such barrier to, in order to achieve his goal.
Before Ali lays out this in more detail, just to make this clear again, everything you've seen so far is fully unauthenticated. You don't need anything. You just need to know the address of a direct access server, and you can connect with this fake tunnel and do all the stuff that we've seen so far. No authentication. You don't have to be a valid client. You can do it on the internet.
Yeah. So, what I saw when I changed when I changed the configuration on the IPHTPS component on the direct access server to force the authentication from the different clients, I saw that by the time I connected to the direct access server here using this authenticated tunnel, I saw that all the packets actually with multicast addresses are forwarded, unless the packet again is a duplicate address detection packet. But otherwise, all the packets are forwarded. I don't know why, even though the first scenario, all the direct access clients work perfectly, with no interruptions. But in this case, maybe the trust model is changed. Without any, reference like saying why from Microsoft. But in this case, all the ICMP version 6 packets actually can reach the direct access client, even though they are authenticated. But I don't know why they do this. So there are sort of new attacks that were realized in this scenario that were not in the previous ones. So all the traffic going to the inside, also to the direct access client. So I changed the command to change the configuration on the direct access server. Then I used Mimikatz actually to extract a legitimate certificate from one of the clients to use it for the demonstration purpose. And this is what I got actually when by the time I connected, all the packets coming from the direct access server and from the direct access client without nothing. The attacker can passively scan all the IP version 6 addresses of the direct access server and the direct access clients. So what I did actually, the attacks, I could now scan the live direct access clients using Bing scan, for example. Yes, sometimes it's really too much headache for the attacker because sometimes are well randomized, then maybe run to the problem that he has to scan all the 2 to the power 64 minus 2, for example. Also scan direct access client for open ports because all the unicast addresses are forwarded now. Also, you can deny service all the direct access clients by sending fake router advertisement, ordinary fake router advertisement with randomized prefixes. And actually, Windows operating systems are vulnerable to this attack unless they are hardened. Also, hijacking the IPsec packets. This is really interesting because, as I said before, the IP-HTTPS tunnel doesn't use any layer 2 addresses, but even though the attacker can send like a neighbor advertisement pretending that he is one of the legitimate direct access client, and then the server will be willing to send every IPsec packet as a reply to a response from, to a request from the direct access client. Also, you can now denial of service a direct access client by sending just a router advertisement with unsolicited neighbor solicitation. So you just know the address of the router, which is the direct access server, which is known, and you send with the unsolicited flag and send this packet, and then it will be received by the client, and the client will erase the default router from its routing table. and then will not send any packets to the direct access server. This is the denial of service with fake router advertisement. This is the screenshot from the direct access client. This is all the, inside the IPHTTPS sending, and then the direct access server will forward your packets to the direct access clients, and all the direct access clients will be blocked with these addresses. So this is how I did the hijacking. Actually, in normal scenario, the direct access client sent IPsec. The response will be coming from the server and will be neighbor solicitation, neighbor advertisement after every packets. Then after this one, for example, if the attacker sent a series of neighbor advertisement, the client still sending the same packets, but the reply is going to the attacker. So at the end, the client will not get any response. This is the man in the middle attack that I tried. I tried very hard to forward these packets that coming from the server to forward them back to the client, but I couldn't, because every time I forwarded them back to the same addresses, the server was sending them, back to me. So this is, for example, the first scenario, how I realized it. I was monitoring the traffic on the attacking machine, and then by switching one of the clients, actually, I saw that the direct access server sending me a neighbor solicitation asking for this client that he was just switched off. So then I switched on the client, and I did the same thing by sending neighbor advertisement, series of neighbor advertisement, and then I got this reply from the direct access server. And here, if you can see, this is addresses of 624 tunneling, which this is another security concern for the direct access, because in direct access, even though you are using explicitly IPHTTPS tunneling technology, but you cannot disable the 624 tunneling on the server side, because the addresses of 624 tunneling are used as the addresses of the IPsec gateway on the direct access server. So what I did, as I told you before, I did man in the middle attack. How I did it, actually, this is the router advertisement that usually sent by the direct access server. And here, if you can see, this is also some options that we cannot see in real systems, which tell the direct access client, actually, if you want to go to this subnet, please, this subnet is reachable from me. Then the attacker knows all the subnets that are reachable from the direct access server. So what I need to do, I had to send the same one with the same prefix, with everything, because all the addresses are hard-coded using the group policy in the direct access clients. So I had to convince the direct access clients that all of these subnets and this prefix, for example, are reachable from me. So what I did, I spoofed the server router advertisement and set all the preferences and all the route information with high priority, and I sent this one. And this is the scenario how it goes. I send this fake router advertisement, and yeah. Oh. This is the fake router advertisement. It has the same prefix that it's sent by the direct access server, and it has all the information with high priority. I sent it. It was received by the client, and then the client set up the addresses from this router advertisement, and then the direct access client sent every IPsec packet and started a new connection from the new IP version 6 address that it was configured by this fake router advertisement. And I was able to send this packet through the tunnel between the attacker and the server. So that's it. At the end, one word. The system is very complex, and complexity actually kills. So, yes, direct access is nice technology from the user perspective, but again, it's very difficult to handle, especially there were no, papers or technical papers from Microsoft that discuss the IP version 6 in this technology exactly. And again, some other concerns like infrastructure tunnel that it's built, as we said, automatically without any, even the user logs into his computer. So imagine that the user, the computer of the user, for example, was available for the attacker just for 5 minutes, and with even local account, not even administrator, the attacker can get hands on the infrastructure tunnel. And also 6 to 4, as I said, it's difficult to be disabled. It's not an option to be disabled on the server side. That's it from my side. I hope you enjoyed something, and sorry for the interruption that happened. And if you have any question, please ask me. Thank you.
We may have one question. I hope it's okay if we don't do a long Q&A to stay a bit on schedule.
Yeah, no problem.
Sorry for the constant delays we use.
Yeah.
Any questions? I can say from my side that a number of the things Ali found out quite surprising to us. It was like, wait a second, this seriously Microsoft can connect without any authentication? Just using, okay, we had to build this custom script for the IP HTTPS tunnel, which Ali did, and the stuff will be released. So you can use the stuff on your own. No authentication, and you can connect and map devices. It's like you allow somebody from the internet to kind of join your network. The attacker's not able to build establish the IPsec connection, but he's already part of your network somewhat, and that is.
Sorry. Even if the second scenario, why we do need to forward the traffic to the users?
There is.
Why the trust? Model is
I
changed.
think it's exactly the right conclusions. A complex piece, nobody has so far looked at, and then once you open the box, there's all types of ugly things you see. Again, thanks, Ali.
Thank you.